Hey guys, hello. Hi guys. Am I audible? Just let me know if I'm audible. Hello. Hello guys. Um, so we'll wait for 5 minutes. Just let me know if I'm audible and I will start the class. Okay, audible. Thank you. Thank you, Aman. Cool. Um, so today is the last day for the bootcamp. I thought I'll be able to complete Java in 7 days, but it's a tall order, tough task to do. Right. Today there will be more. So today's session would be like a mixed session, right? It would have uh, some more OOP stuff and hopefully some basic exception handling stuff. And also, guys, don't forget that since today is the last day, if you guys require your need your certification, right? You might have to see, like, there will be a quiz, right? There will be a normal, quiz uh, from from 9 p.m. and 9 p.m. onwards. Okay, so there is a quiz, and you have to score greater than 40% to avail the certificate. Okay, yeah. So so today the stuff that I have in agenda, I'll let you know. Right, today, okay, today we'll learn about you know um, methods, right? Inside this we have some types of methods as well. Okay, and as we saw yesterday we saw we did not see this, right? This particular portion we did not cover yesterday, right? That is what we are going to cover today, right? We are going to cover this today. I'm gonna cut this, right? And I can remove this. So we are going to cover that. Okay, and I'm also going to cover sorry, I have a little sore throat and I'm a little sick, but the concepts are more important than my health. Cool. So I'm going to cover instance methods, right? And also, 1 second, the mic is not so good. Yeah, I'll cover so some exception handling a little bit. I'll give you the hierarchy and everything, and after that, if time permits, I will cover inheritance. Okay, and then maybe also polymorphism. Okay, all of these kind of things, right? So if time permits, I will try to cover them, but yeah, cool. Okay, let's move ahead. Right. Okay. So we have some. We generally have types of. We have a lot of, like. We generally have methods in Java, right? So methods are basically like sub programs or subprograms, and they are of two types, and like they are basically similar to functions in C, functions in C, functions in C, right? Yeah, thank you, Aman, for raising that comment. It takes a lot of time to like try to teach you something good, teach you guys good. Cool. Thanks for the appreciation. Cool. Yeah. So the types of methods we have are two types. We have instance methods and we also have static methods, right? Okay. So we have instance method and static methods. I'm audible, right? I'm perfectly audible. Yes. We have instance methods and static methods, right? I'll just show both of them through examples, right? The examples that I would write would be something like, let's say let's say I have a class. I have a class called calculator, right? In this class calculator, I have like a void add function, right? Inside this I have an integer x, integer y, right? And I since so it is just going to print right, it is going to print sum is equal to, right, x plus y is what it is going to print. That's it, right? And if let's say I also have void mul method, right? This is for multiplication, right? So if I have multiplication method, again it just takes int x, int y and it prints mul equal to x into y. That's what it does. That's it. Okay. And these are the two things that this calculator is capable of, right? This calculator is capable of addition, okay, addition, and then multiplication. You can go ahead and add, subtraction and division, all of those kind of things. Yeah, but I will keep it limited to this particular thing, right? With this particular calculator, what we can do is we can always obviously create another class, right? Or maybe we can okay, we can create another class. Let's say calculator demo. Okay, in this class what we are going to do is, okay, in the calculator demo class what we are going to do is we are going to make a calculator object, right? We are first having a PSVM string args, and then we are going to make a calculator object, and the calculator object we are going to make is calculator calc equal to new calculator. As I told you yesterday, since there is no constructor given, there is no constructor for the calculator, JVM provides a default constructor, right? Here we are able to do this because there is a default constructor provided by Java virtual machine. Okay, so this is valid. Okay, and now we will be able to create a calc, right? And if we just do calc dot add 100, maybe 200, right? What are we going to get here? We are going to get 300, right? And if we do calc dot mul 100 and 200, right? What are we going to get here? 100 into 200. What is 100 into 200? 200 plus 2 zeros, right? Extra zeros, right? So this is what we will get, right? So what has exactly happened here is what I'm asking you, right? What has exactly happened? You create a calc, right? You create a calc object, and inside your memory, your calc will point to, right? It will have certain piece of, in from the heap. This is from the heap, right? Some memory, right? For every object for every method that you have, for every method that you have inside the class. These methods are basically just subprograms, right? So having having the entire definition, the entire piece of code inside the class, inside the memory of the object, does not make sense, right? So you can think that definitions of like whatever is the code definitions, or you can say, or code of methods of a class are stored in code section. Okay. All the definitions are stored in a code section, right? So what do I mean by code section? Yesterday I explained, right? Yesterday I explained that there is this particular section right here, right? In here you'll have the definition being stored, and whatever is the definition, by definition what I mean is, this piece of code that you see here, is being stored in the code section, and that particular code section will definitely have the memory, right? In this particular calc object, it will have a add as a reference, and mul as a reference, and they will point to some particular memory area where that same piece of code, where the same piece of code will be available, right? So maybe for add you can find that piece of memory in like 3569, right? And maybe for for multiplication, the piece of set of lines of code can start from 4293, right? It can start from 4293. And so whenever you call calc.add, what happens is, from calc it will go into the add particular reference, and it will start executing. Since it's a method, right? Since it's a method, JVM knows that if it is a method, the signature is a method, right? JVM knows to go into the calc and then go to add and then start executing from 3569. It will keep on executing 3569, 3570, 35. So all of those instructions it will keep on executing from in the memory. As soon as there is a return, it will return to that particular position, right? And it will start executing from this line. That is what is happening here. And I think I explained pretty deeply yesterday how a method is, like, not yesterday, maybe in one of the classes, how a method is called, how like the stack is used, all of those kind of things. Hi Venkateshwara Ankem. Thanks for joining the class, right? So this add and this mul, their definitions, their particular code, right? The code that you see for them are stored in a common area, right? And all of the particular objects of this particular calculator, or all of the instances for all the classes, will go and access that same particular area, same memory area, and will be able to save access that code, right? Because having code written for every particular object is going to consume a lot of space, and that we want to avoid, right? We want to avoid that. So that is the reason these methods that are there for a particular object, these methods, okay, so methods inside an instance or object, okay, are instance methods. Cool, got it? They are instance methods, very simply. That is what the whole funda is, right? They are instance methods. Okay, yeah, got it. So I'll move forward. Okay, these are instance methods inside an instance or object are instance methods, right? So we have covered this particular portion, right? Now we will cover this one, static methods. Yesterday I mentioned that there is always a this particular static area, right? Static area. This is where you store all the static references, static global variables, all of the thing, right? So so your class, whatever class you make, right? Let's say you make a demo class, right? Let's say you create another class. Okay, you make a calc demo class. Okay, and inside calc demo you have a static void. You made a static void add, and you have int x and then int y, whatever you have, right? And then you are going to just do s out. You'll say sum equal to x plus y. Yes. Now when you do this, you can obviously call the PSVM here, string args. Inside this, you can use the same class, this particular class name, right? You can use the same class name called calc demo. And since it's a static variable, what did I say? Static variables from yesterday's class. If you remember, static variables can be, where is this particular thing? Yeah, here I think I mentioned that this particular point, class name dot static variable name, they are global to a class. They are global to a class, right? The same thing applies. The same thing. This particular add, okay, this particular add global to a class slash instance. Okay, so this particular add will be stored will be stored will be stored again. Where is it stored? This particular add will be stored in the, I'll just copy this so that it's there with me. Will be stored. Okay, I'll just copy this, paste it here. Wait, paste it here and delete. Right, so this particular add that you see, calc demo will go and actually sit inside the code sorry, not calc demo, the add particular function will go and sit inside the code section, right? Inside this code section, but the add reference the add reference will exist inside static global variables. Okay, adds reference will be available here. Previously, for instance method, the adds reference, the reference for this particular method, here, because they are not static methods, they are actually available in heap, the object. The reference will be inside the object. The reference will be inside the object, inside the heap that it is creating an object from the heap, and it is referring the place inside the code section wherever is the code starting from. But when you say calc demo dot here dot add, I'll just write the full code, calc demo dot add, and then 10 comma 20, right? You will get 30. Okay, and right, So this particular add function, okay, the reference is in this particular static global variable, right? But the code still remains in the code section. Okay, so that is the whole point here. That is the whole point. Okay, so that is what is happening with a static method, and it is the same with static variable as well. Static variable, the variable itself would be available here. Okay, and the reference would be available here, right? Because variable, since it's a small variable, it would be there. But if it is an object will be in the heap, right? But your variable reference would be in this particular position if it is a static object, right? A primitive, for a primitive you don't need anything. For a primitive you can store the variable inside the stack, If it is a static object, if it is static variable, then you will store inside the static page, right? So there is a minor difference. These are some minor differences that you always have. So you can use the name of the class and you can call the add function using, if you have a static method. Also one more small caveat is that if you have a static method, right? So let's say you have like another method, let's say you have another method, say int, let's say not int, void addition, right? You can just do int x, int y. From this method, this is an instance method. From this method, you can call a static method, just like that. Calc add, or let's you can call a static method in any fashion, right? Let me just remove this 1 second. You can call a static method like calc demo. You can refer to the same class and you can say add, and you can call x comma y like this. Okay, you can call a static method like this. Okay, so in this particular method, you can also call any other instance method as well inside this particular same class. Okay, but let's say if the calc demo class, let's say if we are not creating in the instance method of if we are creating instance method for some other class, in that case as well I can still use calcdemo.add, right? Calcdemo.add, because it's a static method. Any other method in any other instance can also access this method. Okay, now there is a concept of access specifiers. Depending on that we can either access it or not. Okay, for now we will not look into that. That's a separate topic altogether, right? Okay, now we'll move on. Yeah, so yesterday we learned that there is one principle for OOP. There is one principle and 3 pillars. The principle is basically abstraction, right? Abstraction. What do I mean by abstraction? It's an idea, it's a thought, right? It's a thought. And this idea that you already have, like thought or anything, right, generally is void, or like you can say is void of implementation. What do I mean? Like you don't care about how it is implemented. Okay, right? A very famous example is that you know how to ride a car, but you don't know how the engine is working and all, right? So that is a very famous example given in colleges, and I would use that same example as well because it's a very good example, right? Now these 3 pillars that I taught you yesterday, one is encapsulation. I think we went a little deep into what encapsulation is, so this is done, right? And the other is polymorphism. This we will look into today, and if time permits, right? And if time permits, we will also look into inheritance, right? And abstraction. So all these three support what? Support abstraction. Okay. And one more thing. With abstraction, we also have a concept of with abstraction. We also have a concept of with abstraction. We have a concept of data hiding. Okay, data hiding. How do we add data? Okay, how do we hide data? Sorry, not add. How do we hide data? Right? With abstraction, what are we saying? You don't need to care about the implementation. With abstraction, is what we are saying is that you don't need to care about the implementation. You just give me something made up, right? I will take care of whatever has to be implemented. With data hiding will support abstraction. How do I achieve data hiding? I achieve data hiding using access modifiers. Okay, access modifiers. Broadly speaking, there are four of them. Okay, one is default. Another one is private. Another one is public. And then the last one you might have heard is protected. Right? If I talk about what they generally do is with private, okay, access to member is strictly within class. Okay, with default, access to member is within class and package. With public, access to member is within class, package and everywhere. With protected, access to member is within class, package and subclass. Now you might not know what is the meaning of subclass there, right? So you will know what is the meaning of subclass very soon, right? So and subclass. So these are the four access modifiers that you have. By default, let's say here that you added void addition, right? By default, no access, so no access specifier means it is default. So this particular piece of code, okay, means the same as, right? This can be redefined as default void addition. Okay, this particular piece of code, both are same. So I would write 1, 2. 1 and 2 are same. Okay, cool. Right, so whenever you don't add a specifier, it's default. If you add a specifier like private, public, protected, right, then it's definitely it will try and do stuff related to that regarding whatever is written here. Okay, and you will understand this if once you understand how you can access what are subclasses. and all, right? Here the protected part, you'll need to understand what subclasses are and all of those kind of things. Okay, and packages, I might not be able to cover what packages are, but think of package as code which is within a folder. Within one folder you can create a package. Actually package and folder both mean the same, right? Okay, now moving forward, right? How do I achieve data hiding then, right? The way we can achieve is, let's say I have a class called account. Okay, in this class I have a member called double balance. So by default, since this is default, this particular piece of code, code is default. So any particular class, let's say I have a package called src. Inside this src I have more stuff. I have a package called accounts package, right? Inside this accounts package I have more code, right? And one of the classes is account class, and then one of the other class is bank, or maybe accountant class, whatever it is, right? So if this is the case, since I already told you that this particular default will allow access to member within class and package. So if there is something else inside the class, it can access balance, but it can also allow access to the same member balance. If I create an account object, I can easily access it in the accountant class as well. If there is another class, let's say clerk class, for some reason there is a clerk class inside this particular object, right? So clerk should not actually have access to a balance, right? They should not, they definitely should not, right? And even accountant should not have access. So for example, if I really don't want direct access to my balance, because if accountant wants, they can directly do, for example, inside the accountant class, if I say inside the accountant class, if I have accountant class, right, inside the accountant class I have a method called void change, change balance, right? If they want to change balance, they can very easily change the balance. They can just say new account. They can create an account, right? For this new account, they'll just do balance equal to 500. They can easily assign. So this should not be possible. This kind of a thing, this kind of a code is not good. Okay, one second. This kind of code is not good. This is a bad practice. Since account does not want to, for accountant, since account, here the account does not want accountant to look into this code, what account can do is, it can make this particular piece of code, this particular piece of balance as private. What it will do, I'll tell you, right? It will go ahead and take this double balance that it has, copy this, right? And then it will do one thing very clever, very nice. And what it will do, it will take double, one second, right? And it will just do it, make it private. Now once it is private, what did I tell you? What is the rule of private? Private rule is access to member is strictly within class. What do I mean by that? Outside, even if I make a accountant, I will make an accountant, right? The accountant is already available above, right? I'll just take that. Thank you very much, right? I will take this particular accountant class, right? Even if I have an accountant class, what will happen? This accountant class, right? This accountant class, one second. Okay, this particular piece of code, this there will be an error here. Okay, and this would be a compile time error. Why? Because this balance, this particular balance cannot be accessed by accountant, because I have said that account in the account class, I have said that account is, the balance is private, right? I have said that the balance is definitely private, so I cannot now go ahead and access new account dot balance. This is not possible now. Okay, so that is what my example is saying. If you want to hide the data, hide the actual data inside your class, you can use access modifiers. That is one way of supporting abstraction, right? And one more abstraction is you are encapsulating the entire thing into something known as account. Now the user, the person who is using this account, does not need to know how the user is storing account. And if someone is accountant, right, some particular accountant is having accountant classes there, right, the person who is using this accountant need not know whether they have change balance, whatever they have, they don't need to know. So class comes into that picture, right? There is encapsulation there. Now this is all about access specification, access modifier, right? We will understand. So default, private and public. Obviously if you make it public, anywhere you can access, anywhere. You don't need it to be in like a particular in a particular place, or like try to access it in this place or that place, right? Anywhere you can access. Anywhere, it doesn't need to be in a package or anything like that, right? So that is what the entire understanding of data hiding is, and this is data hiding. Okay, now, so abstraction, what do we need, what do we mean by abstraction? Again, what is abstraction? Abstraction is hiding internal implementation. Okay, hiding internal implementation, that's it. That is abstraction. Okay, now how do we achieve this? We can achieve this via the three pillars that we have. One of them is encapsulation, that we have already seen using classes. Okay, the other one is what is the other one? The other one is polymorphism, and the one after that is inheritance. Okay, hiding internal implementation, right? And we can add, on top of this, we can add data hiding. Okay, using how? Access modifiers. Okay, now a final example of what I am talking about is so a final example would something like, you will have a class, let's say you have an account, right? Inside this class you have private double balance equal to, maybe it is initialized to 300, right? And then you have a public void set balance, you are passing in double D, and then you are saying balance plus equal to, or you can obviously say not set balance, you can call this, maybe update balance. Okay, inside this you can pass double the d variable and then balance plus equal to d. I can do that, and I can also say public void set balance. Here I can just do double t and balance will be set as d. I can also say public I can say double get balance. Okay, this time there is no parameters, and then I can just return balance. Okay, now in some of the textbooks you will see that this particular thing that you saw here, okay, this particular thing that you saw here, you'll call them setters. Okay, what are they doing? They are setting data. Right here, data is being set. What data? Like internal property. What is the property here? Balance, right? And in and also you will also see that these are getters. Okay, and they generally getters return properties or data, right? And you have seen, I am very carefully telling you that this here we have a private, and all of these guys are public. So once they are public, if I have an instance of account, I can just do, let's say I have new account in some other class, I have created an account, and from that I can set balance. Okay, I can call set balance on that and maybe pass 500.6, right? Something like that. You can create a client and then client class like an account demo or something, and then you can obviously create an object of account, and then from that object you can call from that object instance you can call update balance, set balance and get balance. Why? Because these are public. Okay, and this is private, you cannot access this balance cannot be accessed, right? Very quickly let me show you that. Let me show you what I mean, right? Let me show you. Okay, I'll just say account.java. Okay, and this time, yeah, maybe it is a public account, public class account, right? Inside this I will have, so so guys, is my screen visible? Hi Rajyogi, good evening. Right, is my screen visible? Just let me know if the screen is visible, right? Right, yeah, I think it is visible, right? So in this we will have like a private double balance, right? I would just have a public void update balance function, inside which I have a double, let's say d variable, right? And inside which I would just say balance equal to d, and I also have a public void set balance, inside which I would have a double, let's say d, and then balance equal to d. Here it should not be equal to d, it should be plus equal to d. I will have public, and then I want the balance, get balance, and then I don't want any parameters, I can just do return balance, right? And this is how I create a balance class, right? And inside from this balance class Inside this balance class I can have definitely the, I don't want, okay, I can do something like, so this might not be public, I don't want this to be public class, and maybe what I want now is to make sure that I would create a class, right, class account demo, right, whatever this class is. Inside this class I have our PSVM, right, and I have created an account, right. I will just create a new account, right, and that account is assigned to maybe account AC, right, and this AC, you see here I have get balance, right, I have set balance, I have update balance, I don't have balance, I cannot access balance. This is not possible, right? How do I not be able to access that? Because here balance that you see here is a private, right? Now if I make public, right, you will see that there is no issue. Syntax error, variable declarators to complete local variable. Yeah, so for example, AC dot, if I do AC dot, I can see it is showing balance, right, and maybe I can just print it, right. So if I make this private, I won't be able to show. This is a compile time error. Compiler won't even let me go through, right, if because this is private, but I can obviously update it, right. So I can update it. First let me just do AC dot update. Before even updating, let's just set the balance. Set balance, maybe I can set the balance to, I have like let's say I am poor, right, I have 500, that is my balance, right. I can do AC dot update balance. I won a lottery, and in the lottery I got like 10,000, right, and now if I want to check what my balance is, right, I can check my balance by just do AC dot get balance. Now if I want to run this, right, I'll just open my PowerShell, ls. If I do, I have account.java here, right, I'll just clear my screen and I'll just run java c account.java. That if I do ls again, I see that there is a account class, right. I'll just clear my screen. Once I clear my screen, I will just do java account, that's it. Wait 1 second, main method, please define the main method as public static void main, or a JavaFX application must extend JavaFX application dot application. Let me just see what is happening. Acha, okay, I created two classes, right, okay, sorry. So I have account demo as well, right, because I have created two classes, right, both of them got compiled and I got account demo dot class, so I'll just run account demo, Java account demo, right. I got 10,500.0, right, that is because I first set the balance as 500 and then I have set the balance as update the balance with 10,000, and so the current full balance is 10,500, right. So if you don't want to get into all this confusion, right, what you can do is you can create a public static void main inside your here, and you can obviously create the object from inside as well, right. And I'll just take this class and then just delete it, so that it's just simpler to understand what is actually happening. Java c account dot java, right, and now if I do java account, there should be no issues, right. Okay, Yeah. So whenever you create a class, a dot class file extra gets created for that particular class when you're compiling the class. So so you might have to be careful where exactly main is written, and then you might have to write main for that, right? So this is what the program is for your abstraction, and how you achieve using setter, getter, and all of those kind of things, right? I will get back to the iPad now. Okay. Yeah. Okay. Yeah. So that is what the program is. Now, let's look into something known as exception handling. Okay. Let's look into very basic intro, right? Intro to exception handling. Intro to exception handling. Intro to exception handling. Okay. Actually, in exception handling, there are so many topics, right? You have something like so there are actually a lot, right? But let's now focus on what exactly is an exception, right? What is an exception? Exception, right? Exception is that unwanted and let's say unexpected event, okay, that disturbs the normal or natural flow of the program. Okay. So unwanted and unexpected event that disturbs the normal or natural flow of the program is an exception. That is what an exception is, right? So what do I mean by exception handling? What do I mean by exception handling, right? So very brief about it is basically let's say I have 3 lines of code, right? I write S out statement 1. Okay, and I have S out 10 by 0, not 10 by 10, 10 by 0. Okay, and I have another S out statement 3. Okay, what exactly is happening in the JVM is that this particular piece of code, according to the syntax, okay, with respect to syntax, you know, Java compiler says this is okay, correct syntax, okay, right? But when you run it in your, try to run it in your system, when you try to put it in your system, right? When you try to run it in your system, what is happening is this line would go well, but this line, right? You will get your program will terminate from this line. Program terminates here. Why did it terminate here? Because we have an unwanted piece of code here, basically, right? This piece of code is literally unwanted. Why is it unwanted? Why is it unwanted? Because in mathematics, math doesn't allow division by 0, right? In terms of syntax, right? In terms of syntax, this does not violate anything, right? 10 by 0 is fine while writing it, but when running it, your JVM will say, boss, this is not correct. This, I cannot divide anything by 0, right? When you divide something by 1, that's fine. and that is the reason you would say you would get a arithmetic one second, you would get a arithmetic exception. Okay, that is what you will get. Okay, okay, got it. Now because of this problem, because of your program getting terminated here, all of the lines below this, right, let's say there is statement 3 is there, right? After this there is a lot of important lines that have to be executed, right? All of the lines below this won't be executed. Your program will stop executing here. Okay, your program will stop executing here, right? So this particular piece of code, this particular piece of code, this code never executes. Because why? Because the exception was never handled. Okay, was never handled, right? The exception, what do I mean by the exception? This particular thing, the exception was never handled. And handling code that can lead to an exception, okay, to an exception, is known as exception handling. Okay, that is what exception handling does. Got it? Very simply, that is what exception handling is. Now there are ways to do this, right? I'll tell you a very basic way to do this. Okay, a very basic way to do this is, okay, a very basic way to do this is, you can write something like, okay, I can write s out statement 1, right? And then I can write try. Inside this try, I can write s out 10 divided by 0, and I can write a catch. This catch can catch any kind of exceptions, right? For now I can catch arithmetic exception, and I will name it as EX, and I can just print, okay, I can just print EX exception occurred, okay, and maybe I can just do EX dot print stack trace. Okay, now don't see these particular things and then be like, why is the function print stack trace and all, and then we have statement 3. This is what is happening here, that is, this is what we have, right? Because of this particular piece of code that we have, our output that we see, okay, one second, our output we have would be, first statement 1, and the second thing that we would get is some exception information, exception info, okay, and the code keeps on moving, right? The code, because you have caught it, you are saying, okay, it's fine, I have caught the exception that has happened here. So with try block, what happens is, inside try you keep all the kind of code which can always go wrong. Which can go wrong? Let's say you took this input from the user, right? Let's say you took 10 from the user and 0 from the user. In that case, what you can do, you don't know what is A by B going to do, right? You don't actually know what A by B is going to do, right? If you don't know if B is equal to 0, then you will definitely come into a situation where there can be an exception, right? There can be an exception. So always write inside the try block, always write code that can go wrong, that can not go wrong, that can raise exception. Okay, that can raise exception. Okay, so that can raise exception. And if there is an exception, that occurred, from it will go into the catch block. This is known as the catch block. Inside this catch, you generally can take any exception, okay, using the name of that particular exception, whatever. This is the type of the exception, and then this is the variable of the exception. This catch block, okay, in this catch block you have named it EX, and this is a arithmetic exception. Instead of exception, you can also, instead of arithmetic exception, you can simply write exception as well. That also works, right? But you know that it is specifically going to be arithmetic exception, so you will write arithmetic exception, and then you can print something. You can do anything you want inside this catch. This will only get triggered if there is an exception here. Otherwise, if this works, then you will start executing from this line, right? And so on, so forth, you will start executing, right? So your output will actually be, even if there is an exception, it would be either this, either statement 1, statement 2, or your output would be statement 1 and then statement 2, or like whatever is the answer. Like let's say here we are scanning them. If we are scanning, like, or if we are taking, not scanning, using scanner, if we are taking input from user A by B, right? In that scenario, here you would get something like whatever is answer of A by B, and then you will get statement 3 here. So something like this. Got it? It's like that. Okay. Very simple. Very simple. I'll try to show this to you on the laptop if it is possible. Let me just show this. Okay. I'll try to create another file. I'll call it exception handling demo.java, right? And in this exception handling demo.java, what I'll have is I'll create one more, how do I call it? Okay, yeah, I can create, okay, I can import, first of all, I can import a scanner, import java.util.scanner, right? Once I have imported that, right, I'll just have PSVM. Inside this PSVM, okay, I can just say try, right? And before even try, I want the A and B, right? How will I do? Int A, first of all, I need a scanner object, right? Scanner S equal to new scanner, and to scanner I will pass in system.in, right? And then I can do int A equal to s.nextInt, and I can do int B equal to s.nextInt, right? I can just do s out. Let's say I'll just do statement 1 here, and inside this try I can write s out A divided by B, right? And then I can catch, right? Inside this catch, I know that it is going to generate a arithmetic exception EX, right? And this particular arithmetic exception, I can just do EX dot print stack trace. I can do that, and I can obviously write s out and just say like exception occurred, whatever it is. And I can also add one more catch saying if there is any other kind of exception, then I can do ex here as well, and then I can do ex print stack trace, and yeah, that is it. And let's say I want to print here, I want to print statement 3. Okay, now this is the full code. This is the full code. I hope you guys are able to see this code, right? Since I have added try catch, it should be working, right? So now let's go ahead and since this is a scanner, I have to close it as well. S dot close. So yeah, but this is the full code. I hope you guys are able to see this code, right? If this is the code, what we can do is we can go to this particular place, right? I'll just do ls, and I see that exception handling demo is here, right? I'll just do clear and then java c exception handling demo dot java, and it has created me. If I do ls, I see that it has created a exception handling demo dot class, right? And I'll just clear it, right? And I'll write java exception handling demo. I don't need this dot class, I don't need this. I can just write enter, and since I have asked for scanning, right, I'll just do, instead of trying to do this, I'll just write s out what is the first number, right? And then I'll just do what is the, so there is some output second number, okay? And now if I try to stop it, I'll just do java c and then again java, right? What is the first number is asking, right? I'll just write maybe 84345, right? And the second number, maybe if I do 32952, right, I would just see that it is printing correctly statement 1 25, statement 3, right? If I again try to run the same code, right, let's see what happens. Now I can take like 9032 and let's say 0. I am printing statement 1, I am printing exception occurred, and I am printing exception, arithmetic exception, and then it is saying divide by 0, and it is also showing exactly at which line I am getting exception handling demo.java line number 12, right? If I go to line number 12 here, it is exactly this line where exactly is the problem. It is showing me as well, right? It is showing me exactly where the problem is. This is what print stack trace does. It will print you where exactly is the exception occurring from, okay? And I am moving on with my execution using, I am now printing statement 3. Got it? This is exactly what is happening, okay? Very simply, that is what is happening here. I am now printing statement 3. Where is the statement 3? Statement 3 is actually outside the try catch, and I know that there will be an exception here. So if I know, if I am writing the code, I am definitely going to write making sure that there is no issue, right? Okay. Now one more thing, right? If I try to do this, right, maybe I try to use a character a, I am getting an exception, input mismatch exception. Where is it? Where am I getting it? Exactly speaking, line number 7. Here, line number 7. Even this, if you are not sure you are going to get correct integer or not, if you are not sure you are going to get an integer, even this you should put in a try catch, right? And internally it always, like now the one I showed you, that if there is an exception without a try catch, the entire code has stopped running, right? Here it is saying at line number 7 I am expecting an integer, but you are giving me character a, right? And it has stopped executing the entire code, right? And so this is a very good example of what an exception means, right? Okay. So this is what an exception is, how you generally handle try, catch and all. I'll give you further details now. Okay. Hope my screen is visible. Right? Yeah. So let's move on. Okay, right. So that is all about, you know, exception handling. It's a very basic stuff of exception handling, but let's go a little bit deep and let's understand class hierarchy as well for exception handling, right? Uh, you can obviously learn all of this on your own, obviously, right? Uh, yeah. So this is all about exception handling, um, right? Now, before even moving forward, let's go ahead and learn about what inheritance is. Right? To understand the class hierarchy, inheritance, I'll also write that it is a relationship here, right? Okay, we will understand what inheritance is now. Okay, now, so first and foremost point, direct point, right? We to achieve, first of all, to achieve to achieve inheritance in Java, we use extends. We use extends keyword. Okay, and the second part, we use inheritance. We use inheritance to avoid writing excess code, right? Mainly this is used for code reusability, okay, and as well as it implements the concept called dry. Basically, don't repeat yourself. This is what dry means. You should always make sure that you never write the same piece of code every time. That is not what you always want. You want to make sure that you are writing code which is across. It should not be like you're writing the same piece of code, like there is an ad and then you're writing another ad somewhere, right? And all those kind of things should be avoided, right? If there is an ad, then there should be only one ad in the entire code base. You should never write code which is not that great, right? Always remember that you should never write code which is going to hurt you in the long run. Okay, and repeating yourself is the biggest sin or pap or whatever you want to call it. That is what your problem is, right? Okay, cool, understood. Now, okay, right. Now, we are going to take some example. We are going to take an example of animal class. Let's say we have an animal, right? Broadly speaking, we have animal, right? What do you think animals, properties are? Animals' properties are basically that it has legs, right? It has ears, yes. It has nose, yes. So I'm saying this is my general animal that I'm trying to make, and then in this animal, we also have something known as behaviors, and the behaviors are also like it can eat, it can sleep, right? And it can also maybe it can also sometimes, so I'm saying it can eat and sleep is one of the two things that I want to make sure I fix it, right? Because not all animals can run, right? Where not all animals can run. I would say some animals won't try to run, right? So I would say these particular things I'll fix, right? It has legs, ears, and nose, right? Now, this animal, this animal, right? If I have this animal, right? If I say I have a dog, okay, and this dog, if this dog inherits, basically it extends animal, okay, inherits this particular animal class. Whenever it inherits this animal class, it will have all its, you know, all its properties and its behavior in like and its behavior already with itself, but it can also add some more stuff to it, right? What kind of a stuff it can add, right? For example, right, you can say that dogs basically like to run, so it will say I am going to add a run, right? And let's say dogs basically want to run, they can add run. And also sorry, so it has legs, ears and nose. It already has legs and ears and nose. It is assuming that these legs and ears and nose are what I have, right? Right, let's say dogs say that I have eyes as well, right? I'm not saying that all animals don't have eyes, right? I'm not saying that. I'm saying my animal is saying I only have these properties. My animal that I have defined, I only have these properties. Okay, that is what I'm trying to say. Now from these animals, let's animal, if dog is the one that is extended this animal, right? I'm saying apart from legs, ears and nose, this dog, my dog, also has eyes. In the model of my dog, in the model of my class, I'm saying it also has eyes, right? In the same way, if I create a system, where I say there is a teacher, okay, there is a teacher, and to that teacher there is a name, okay, and that name is a string, and there is an age, and that age is an integer, and if there is a salary, that salary is a double, okay. This teacher, right now I am not focusing on the behaviors of it, right? I am not focusing on what kind of behavior does the teacher have. Right now I am only focused on how is the teacher working, right? Now this teacher, now there can be like in so there can be a student as well, right? And this student, right, can also have a name called string, right? Can also have an age called integer, can also have a salary, not salary, maybe it will have a roll number, let's say called long, whatever that roll number is, right? Right, I can do this, I can definitely do this. I can see here that there are two particular fields, right? There are two particular fields which are common, right? Can I not have these two fields in a separate, class, a separate class? Let's say I make another class called human. Inside this human class, what I'm saying is I'm going to have a name called string, okay, and I'm also going to have an age called integer, right? And I'm going to say this is what I am, right? Now both teacher, one second, so both here, let me just say, so this I'll take and I'll put it here, this I'll take and I'll put it here. So now if we have a human, right, I can say that teacher can extend human, and in the same way student can also extend human. And also while I am saying that, I can get rid of name here and age here. Why? Why? Because that is what your inheritance does. Your inheritance is doing that basically. Your inheritance is doing that, simply speaking, right? In the same way, I can get rid of string and this, right? And I don't want all of this, right? And I am saying I want my roll number, only my roll number. This is my unique characteristic. My student. So when I am doing this, I am adding an extends here, and I'm adding an extends here. And when I'm doing this, I am adding a is a relationship, is a and is a relationship here. Always remember that inheritance always has to make sense. Just because you are saying that you have a roll number, you have a name, you have an age, right? You cannot just say that if you create something like teacher, it has a name, teacher has an age, right? And then you are saying that yeah, this is a teacher and I am going to inherit student from this. Since both are making sense, I'll just have a roll number here, right? If I do this, here you are saying if you, whenever you're doing extends here, what is happening? Student is a teacher, is what is happening, right? This particular thing is not so easy to understand. This particular way is not so good to make, right? But this way, when you are using this, right, when you are doing something like this, what is happening here? You are creating teacher, you are creating and you're inheriting human qualities into a teacher. So this makes sense. You're saying teacher is a human. This 100% makes sense. Okay. You can say teacher is a human. Teacher is a human makes sense. But when you say teacher, student is a teacher, right? This does not make sense, and you can make a crappy class design, something like this, saying teacher. So I have similar fields. I want name and age in my student, so student can extend teacher, and student is now a teacher as well. So that is what the problem is with inheritance. Inheritance is about code reuse, but with common sense. Common sense is the most important part when you are using inheritance. Whenever you do an extension, whenever you use the extends keyword, right, extends keyword is only meant to fortify an easier relationship. So here you have student is a human, right? Both of these statements, even in real life, and in programming, both of these statements make sense. They have to make sense, right? And that is the reason this class design is much better than this particular class design. This is not so good class design. You can obviously achieve what you want here, but you have achieved more things here by designing something, knowing that the language suits you. Everything is achieved properly here. Got it? Got it? Now, some simple terminologies. This here is known as a super base or parent class. Okay, this here is known as super base or parent class. These two. Okay, I am going to minimize this, resize this, and I'm going to write very small font. Sorry, this design works technically, but doesn't make sense. Okay, right? Why? But doesn't make sense because student is a teacher, which is not correct, right? So these two, some terminology, some jargon, right? So these two are known as child. Okay, these two are known as child derived or subclass. Got it? I'll just say these two are known as child, derived or subclass. Here I'll just write superclass, parent class. Got it? That is what you have in basic understanding of what inheritance is. Okay, got it? Got it? Pretty easy, pretty simple, right? Okay, we will write a very small piece of code to understand what we are trying to achieve here, right? What we can do is we can write a class which is called human, and inside this class, right? Inside this class we can always have a string name, and we can always have a int age. Okay, and we have done this. We have done this, right? Now int age and all of this is done. Nice, cool. Um, and now we create one more class, right? We call class, let's say teacher, extends human. In this class, apart from these two, okay, apart from these two, we have, yeah, I'll share my attendance link. I'll definitely share the attendance link. Just give me 10 more minutes and I'll wrap up the class. Okay, I'll wrap up the class. Okay, I'll wrap up the class. Okay, there is actually some more content to tell, but today, since the class almost got over, I mean, but I'll wrap up the class and I'll let you know. Okay, I'll just share the attendance link. Okay, yeah. So listen to this. I'll take 10 more minutes, right? And we have class teacher extends human, and these particular guys are already available since you extended human. These particular uh, properties are already available here. You can think of it like that. And on top of that, you can create, let's say, long roll number. Sorry, not roll number here. Since it's a teacher, I would say I want a integer salary. Okay, or maybe I also want a way to salary is one thing, or maybe I want a boolean value, or maybe or I can also have, sorry, one second, I can also have integer number of leaves. Since the teacher is a person who has leaves, they can take leaves, right? So they have number of leaves. In the same way, I can use the human class. I can create class student, and student extends human. Okay, now when I do this, this here extends, right? Okay, now when I do this, I can assume that I have string name and int age here. Okay, I can assume that, and on top of that, if I want some more properties of my own, right? If I want some more properties of my own, let's say I want a int, not int. Let's say I want a long roll number, right? And maybe a student also sometimes may have something like, let's say, int pocket money, right? So students can have these kind of things, right? So you are essentially saving what? You are essentially saving lines of code. You're not redefining anything. You know that student is a human, so that's why student also has name and age. Definitely, you know that teacher is a human, so teacher already has name and age. But apart from that, teacher is its own particular class where teacher is a type of human, saying I have a salary, I have number of leaves. In the same way, student is a type of human, saying student is a human, obviously, but it's a separate type of human saying I have a roll number, I also have, sometimes I have a pocket money, right? Apart from these two that are differentiating factors, since they are a human, they definitely have a common name and a common age. They have a common name and common age. That's what you need to understand here, right? They have a name and a common age. Cool? Got it? Got it? You understood? Now, apart from this, there is one very important concept. One very, very important concept. And that important concept is that since I know that there is human, right? Since I know that human, teacher is a human and student is a human. I know that. I definitely know that, right? What I can actually do is when I create an object, what I can definitely do is when I create an object of type, let's say student, right? I can obviously store it in student reference, student s. When I create an object of type teacher t, I can store it in new teacher. That is amazing, right? But 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 since both teacher, since both student and teacher are humans, right? Since both teacher and student are humans, right? Since both teacher and student are humans, I can say that human can refer to student or teacher object, right? What I mean is I can do something like human h equal to new student. I can also do something like human h2 equal to new teacher. Okay, now if I have a function, let's say, now if I want to let's say I have a method, right? Create human. Inside this, if I take a human object h, right? Whatever is sent using to this create human, right? I would just say h equal to, I would just say, let's say I can just say h dot name. I can just say h dot name or like h dot age, right? I can use this and I can call create human somewhere, and I can make a student, or I can make create human, and I can make a new teacher. You are able to dynamically pass in new objects to a parent reference. Okay, this here is dynamic polymorphism. This is a very brief understanding of what dynamic polymorphism. There are more stuff like method overriding and all, right? If there is another bootcamp, I will teach you overloading, overriding, all of those kind of things. But yeah, this is what is a general concept. Okay, this is what is a general concept. Okay, a parent can refer to a child object. Remember, a parent can always refer to a child object. But a child, let's say if I have student s1, I cannot do new human. I cannot do this. This is not possible. Okay, but a parent object can refer to a parent reference. This is a parent reference. It is referring to a child object. This here parent reference, it is referring to a child object. So this is where I will end the class today. There is a lot of stuff that I taught today. Little bit of inheritance, little bit of exception handling, little bit of this and little bit of that, right? There are a lot of things that I taught you today, right? And with this knowledge, you can obviously try and go and check some other tutorials, or maybe try and understand Java code, write Java code, and read. There are a lot of things that you can do, right? Okay, cool. So I will just copy the link. I will, yeah, I'll just copy this. This is the attendance link. Cool. So that is the attendance link. I have pinned it. So now it's a doubts session. Now, go ahead. Yeah, guys. Hello. Yeah, if you guys have any doubts, just please ask me. I have shared the attendance link as well as the quiz link. Go ahead and complete the quiz before 9:30. Late submissions, I mean, if you want to, you can still submit it before 10. Right? And just make sure that you get at least 40%, and you'll get a certificate as well, right? So yeah, so please go ahead, and if you enjoyed this content, please like it, share it, subscribe to the channel CodeSprint. And yeah, I will plug in my, so I think I have plugged in my LinkedIn enough. So this is my linkedin.com/in/Sriram, CS Sriram, and this is instructor profile. This is my profile, and you guys can obviously go ahead and subscribe. Okay, guys, if you guys have any doubts, I'll wait for it. I guess.
Without sugar. Without sugar.
Okay, guys, I'll stop the stream. I'll end the stream. I guess I have not found any particular. Yeah, I have not found any particular doubts from your side. I guess. So I'll stop the stream, and you guys can obviously like, share, and subscribe CodeSprint. You can go ahead and see my profile. Right here is my profile. Right, this is my profile. Go ahead and click on it, and then you can send me a connect request. We can connect there as well. So go ahead. Uh, it was nice. It was a nice bootcamp. Thank you, guys. Peace out. I'll share these notes and everything on the WhatsApp group. Thank you.